I'd like to introduce our first speaker of the last session of the day, Phill Jones. And Phill is head of publisher outreach at Digital Science. He has spent much of his career working on projects to accelerate science through improved communication. He was the first editorial director at Journal of Visualized Experiments and also worked at ReadCube. In a former life, he was a multidisciplinary research scientist publishing in several fields, including physics and neuroscience. Phill is a member of several industry committees, including the STM Standards and Technology Executive Committee and the SSP Education Committee. He's also a frequent blogger and regular contributor to the Scholar in the Kitchen.
Thank you very much. Thanks very much for that introduction. Actually, I get the feeling that today's a little bit of a scholarly kitchen takeover, because I think there's been 3 or 4 of us actually from the kitchen. I have to apologise in advance, just in case. It's 3:30 is not the best time for a jet-lagged English person to give a talk, but I will try to struggle through. If you notice me hunting for words, that'll be the reason. So the sort of thing that Tim asked me to talk about in this presentation are things like data sharing and networks of collaboration and so forth. And it occurred to me that a lot of those ideas and a lot of those innovations are really surrounding open science. And open science is a big and scary word, particularly for a lot of publishers. So what I want to do for the next 20 minutes is kind of tame that concept a little bit and see if I can't explain the reasons why it's of interest and of use to publishers and how you can go about kind of getting a little bit involved, in a sense. So if I've been doing my job okay for the past couple of years, a good number of you should at least be aware of digital science. But just in case you're not, what digital science is it's a private company that has invested in a series of startup companies that this is feeding back a little bit. Do you want to turn down the volume a little bit, because I'm getting a lot of feedback? So what digital science is, it's a private company that has invested in a series of startups, most of which were founded by former academics, mostly postdocs, who all noticed issues in the scholarly communication system and sought to do something about it from the researcher's perspective. And digital science was founded by Timo Hannay and the former CEO of Macmillan Science and Education, who was Annette Thomas. And the idea was that publishing is morphing, in a sense, away from being a product-driven enterprise into being more of a service-driven enterprise, where the new job is to support the researcher at every stage of the research cycle. And in a sense, we've grown as a company, and that idea has grown. And today, I personally think that we're more trying to support the research cycle itself and the flow of information around it to serve all of the stakeholders who benefit from that cycle, including researchers, but not limited to them, but of course publishers and librarians, funders, and the general public. So we have products which go all the way from researchers learning about discoveries to the research that they do in the lab, writing about them, disseminating the results, and maximizing the impact. So what I'm going to talk about next is a little bit about how open science works and how some people are starting to use it in real life. Now, you may have been in talks in the past from people who are open science and open access advocates, and the next slide is going to be a demonstration, a kind of a representation of what that kind of looks like. So that's unfortunately the wrong slide, because that is a picture of Utopia, which from the book by the same name by Thomas More. So that's the way that it can look a little bit from the outside. But what I want to do is in the next few slides, is to give you a sense of how it's not really as much blue sky as that. It's not really as utopian as that. It really is being used in academia today, and how it can be used. So here's a more realistic kind of concept of it. So the idea is, the basic kind of high-level concept is that data and assertions and hypotheses could be the primary research output. So a researcher can be in the lab can do an experiment, they can come up with an idea, and they can put that, straight away into the public domain and enable other researchers to build upon it. That would then lead to this large kind of web of contextual references. Everything is kind of interlinked, and people can reuse data and cite it and reuse ideas. And then further downstream, the narrative, which today we call the research article, is still useful and still necessary in order to present arguments and discuss hypotheses, but it's kind of downstream, if you like, from that original kind of research object, in the same way that review articles are currently downstream of research articles in the current system. So it's a research first and data first kind of approach. Another way to look at this is if we look a little bit kind of beyond the kind of open access debate and look at kind of what open science does, is at every stage of a piece of research, from getting the idea right down to kind of maximizing the impact of that idea, there are artifacts and objects being generated. This can be as diverse as digital lab notebooks and data sets and publications and news articles about the piece of research, and all of these, in principle, can be funneled into the web, made discoverable, and interconnected. There are examples already in existence. People are really already trying to do this. I was at APE back in January, and there was a talk by Baron Mons of the European Open Science Cloud, and he was talking about the kinds of systems that they're doing in the Netherlands, particularly, where they are trying to do this kind of research object-led approach to scientific communication. I won't go into too many details about that. There's a link there. It's on River Valley's site where the talk is hosted, and you can learn an awful lot about the kind of work that they're doing with the Open Science Cloud, European Open Science Cloud. So I'm going to talk a little bit about a case study of how open science can be used, and how open data can be used in a way that can be a little bit faster than traditional scientific communication. Does anybody remember back in 2010, NASA called a press conference, and they made a big fuss about it, and they said that it was going to be a xenobiology breakthrough. And everybody got excited and thought maybe they discovered life on Mars or something like that. And it turned out that they hadn't. What they claimed to have discovered, what they thought they had discovered, was a kind of bacteria in a lake in California, which they thought had replaced arsenic with phosphorus. So every living thing in its DNA, phosphorus is an important building block. And they thought that in this particular bacteria, it had used arsenic instead. And now this is this would have been a really kind of fundamental piece of research and one of the most important discoveries in biology, and would have changed the way that we thought of our place in the universe. Turns out, though, that they were a little bit mistaken, and it wasn't quite what they thought it was. But the saving grace of this was that NASA has a policy in place where they have to make all of their research publicly available and transparent. So they are already kind of practicing a large level of openness. And then, secondarily to that, enter Rosie Redfield of the University of British Columbia. Now, she was able to have a look at the research that NASA was doing, pick it apart, attempt to replicate it, and within a year, through live blogging and showing the research that she'd done in real time, she was able to show that NASA were misled, that the research group at NASA had made a mistake. And it later led to a publication in Science, which was very successful and highly cited. But the beauty of this situation was that it literally only took 12 months for her to be able to show that NASA had made this mistake. And by the traditional mechanisms, I think it would have taken an awful lot longer for that misstep, if you like, to have been corrected. So so not only are people already putting these systems in place, but there's also strong evidence that it can be very effective as a means of getting kind of faster feedback and faster corrections to scientific missteps. So a second aspect that I want to talk about, a reason why we should all be interested in this, this is a fairly obvious statement that I think everybody's aware of, right? The internet has transformed the way that research is done. It's made it much more collaborative. What I think is perhaps less well understood is the way in which this has happened. So over on the left, I think, is the kind of traditional model of how science is conducted. An individual PI would apply for a grant within their own lab, and then they would design the experiment, conduct the experiment, do the analysis, write the article, put it out, and other people would read it and cite it. Increasingly, however, that is not an adequate approach to solving the problems that we're trying to solve. And so we're moving from this cottage industry into an industrial scale version of science in which multiple groups in multiple locations are each contributing to a single unified research project. Think about things like GenBank. Every time you hear politicians talking about curing a disease, they talk about the moonshot to cure cancer. There are things like the Large Hadron Collider and the Hubble telescope. There are all these large projects where data interchange is vitally important, and each individual is doing a small part of a much larger picture. Now here's some data to back that up. This is from a research report from Digital Science. You can download it from our website. It's on our resources page. And without going into too much detail, what it shows is that the percentage of scientific articles that are entirely domestic, which means all of the authors are from a single country, is falling over time. So what that is telling you is that's hard evidence that we've got this much more collaborative environment going on, a much more international, globally collaborative environment. So in that background, it's of course very, very concerning that a lot of the data that we're putting out is not retrievable. So this is from a Nature article, and what it shows you is over time, if you try to ask a collaborating or a contributing author for a copy of the data that they use within an article, they are decreasingly able to find it as time goes on, and that's not surprising if you consider that much data ends up on hard drives under desks, in deep storage, postdocs move on. It's hard to find things because the lack of infrastructure that's in place in order to maintain that data. Funders are taking this very seriously. I think we all know that. Here are just 3 examples of statements put out by major research funding bodies: National Science Foundation, National Endowment for the Humanities, and RC UK. If you look at the NIH, they also have a similar policy. They're all interested in making sure that that data is preserved and communicated and shareable and reusable. A couple of years ago, actually back a year ago, January 2015, Figshare, in fact, did a survey of the major funders in the UK and the US, and these numbers will of course be higher today because the trend is going in that direction, and they found a large number of the major funders are requiring data archiving, and increasingly those funders are putting out mandates that have stronger and stronger teeth, and people like EPSRC, for example, are threatening to prevent further funding going to researchers if they don't make their data available. So this is something that funders are enforcing, and so researchers are going to need to do this, and everybody needs a place to put their data. Speaking of which, if everybody needs a place to put their data, there's an issue that we have to deal with. So far, much of the work towards opening up data and communicating it has come from the structured data people. It's come from the people who are interested in things like GenBank, who are interested in large collaborative projects where everybody's doing a similar kind of research or similar kind of experiment. Everybody's using the same kind of machine to generate the same kind of data and putting it in the same kind of format. So GenBank being a great example. There are examples in geology and in astronomy and in a whole range of fields. The advantage of having structured data and structured repositories is that it's very easily machine readable, and data can be very strongly curated, and it's very simple to do that interchange. On the other hand, there's also unstructured repositories, and these are important because if everybody needs to put their data somewhere, you need a place for people to put their data who are not necessarily doing the kinds of experiments that are supported, the kinds of data files that are supported by the structured repositories. So you need to always have both forms. And on the right, there's an example of several of them that are in place. Some of them are institutional repositories, some of them are private companies, and some of them are companies that provide services to institutions and learning societies and funding bodies and so forth to provide that support But that's something that we should all be aware of if we're interested in data publishing, that we need to be looking at both of those types of data, because both have their purpose. So let's look at it for a second from the point of view of publishers. Why is it that you would be interested in this sort of thing if you're a publisher? Now, here's that kind of timeline, if you like, of a quantum of research. It starts with the original idea down in the top left and goes all the way to kind of maximizing the impact of that idea for the benefit of the researcher themselves and the host institution for their assessment and accountability. Traditionally, a publisher would first of all see a piece of research when it was submitted. You know, back in the paper days, the first time you heard about something was when it turned up as a submission. And then the last time you saw it was the point of publication, where you bound it into a journal and shipped it off to a library. And that was the role of the publisher. It was isolated to that kind of central part of it. But as we're moving towards a more service-oriented role for publishers, things are changing. And this is all of the digital science portfolio products lined up along this train. And as you can see, there's stuff downstream and there's stuff upstream. I think we started going downstream as an industry some time ago. As soon as we went online, things like counter stats and usage stats are examples of downstream engagement with the researcher. We also have altmetrics and things like Simplexics, which is a research management system. And those are ways in which we've been engaging with researchers and engaging with institutions post the point of publication. It's also possible to engage before the point of publication, or before the point of submission, and the earliest point in which you can do this, for example, are products like Uber Research and Grid, where you're actually gathering predictive data and understanding the shifts and the changes in what academia is doing, so you can predict things like emerging markets, emerging fields, converging academic fields, where are the growth areas, where are things shifting, and that sort of thing. And at each of these stages, there's a possibility to learn more about what the customer needs and to better serve them. And so in the middle there, we also have things like LabGuru, which are products which are actually helping research tools and a digital lab notebooks. So I think this is something that's already happening in the industry, and I think we're going to see more of that as we provide services. We're going to be able to engage and learn more about what our customers actually need and want, and that's going to be a source of valuable business intelligence as things goes on. So that's my emerging trend. That's one of my emerging trend predictions, if you like, is that business intelligence is going to be a result of this, or the ability to do business intelligence is going to be a result of this improved engagement. And one more prediction before I finish, something that I'd like very much to see, and I hope we do see pretty soon, is the integration into workflow products that I think that a lot of tech companies, a lot of software companies and publishing companies are beginning to get involved with. What I would like to see is the ability for a researcher to put their data directly into a digital lab notebook at the point at which they take the data, and then for that data to be compliant with their funder mandates, with their institutional mandates, and so on and so forth, so that it can then be aggregated through some kind of repository aggregator and directly deposited into a data repository, either at the point of publication or after a suitable embargo. And this needs to be integrated into a workflow so that it is easier for researchers to do it than currently it is. So currently the situation is that a researcher will publish an article, a piece of research, and then they, post-publication, are often asked by their institutions to put it into a format suitable for deposit, and this is very often a post hoc process. Data is lost, and so I would like to see much more integration of data publishing into the workflow of the researcher, and I believe there is something that publishers and librarians can both add to this. So that's my second prediction of an emerging trend, if you like. And that is all that I wanted to say. So thank you very much for listening, and I'll sit down. Thank you very much.